All right. I've heard this plenty of times from people like Flat Earth Dave, where they say you can't measure the ground by measuring the lights in the sky. Well, I thought, how much of a funny idea to actually try it. It's just a very strange theory. We have like a floor to ceiling scenario here. Obviously, with curves, you get a position on the actual curve itself. But I'm just doing a floor here because that was what they were saying. You don't measure a floor with the lights in the sky. So that's that was his challenge, I guess, measuring the floor using the lights. Now, why would you do such a thing? Well, in this particular instance, there seems to be a very big problem. A hole has fallen in the floor. It's now too dangerous to go and measure it the formal way. There's a friggin' shark in the floor. Very, very dangerous. I don't know about you, but I'd like to keep my legs not eaten off. So, how do you do this sort of thing? Well, I have set up this plan here. I'm going to make it bold so you can see. That's just too strong. I'm not going to make that. I'll just continue with the way it was. Okay, so the objectives for this particular thing. Avoid the friggin' sharks in the floor. So you can't measure it the old school way. You actually have to use the lights in the sky. Establish the ceiling height. So that's my first objective. This drawing has... I haven't put any particular scale in there. I don't even know what the result's going to be. So you're going to learn with me. So if it fucks up, it'll be fucking up live. The final thing is establish the room width. So once I figure out where the ceiling is, I'll figure out what the room width is. Now, have floor targeting point 300 measurement units away from both side walls. So when you look at this, I'm just going to start at 300 per side, because if realistically you were using some sort of angular device, you wouldn't stick it right in the corner of the wall. You would just say, okay, I'm 1 foot away, or I'm 300 millimeters away from the wall. I'm going to start from this point. I'm going to triangulate it from there. So I've set that up. So we all know that you can just measure 1 foot. That's pretty easy. You just get measured tape out, bang, done. So 300 units is a buffer, so the work can be done. All right. Now, use angles A and B to establish a ceiling height to the downlight or downlights. All right. Now, what I'm going to do is I'm going to use a Google randomizer. And what I've done is I've put the tolerances from 40 degrees up to 86 degrees, so that I'm sort of in that range where it would point at a typical downlight on a roof. If I made it 1 degree, the downlight would be so far off to the left, it'd be just ridiculous. And if it was at like 91, well, it's backwards. So I've tried to keep the tolerances to something you would expect for a room. Now, to set angles A and B apart by a controlled factor of 1000 measurement units using points X and Y. So this is point X, which is 300 mil or 1 foot away from a wall. This is a controlled measurement here, 1000 units, and that's the point Y. So this is to create something that's set, something that's you can rely on as a point of reference. So you got 1000 measurement units. Now, establish the position of downlight 1. Use angle C to downlight 1 to establish the opposing side, point Z, and then establish the room width. So, as you can see here, got a gaping hole in the floor, got freaking sharks in the center, right? Now I've set this point Z on the opposing side with another 300 mil of units in a buffer on the side there. And so angle C will come back, and we'll be able to hopefully measure the width of this room and set it up. Okay, use angle C to downlight 1 to establish opposing side, point Z, then establish room width. Okay, room should be measured for ceiling height and width. So let's randomize this. Now, there's one catch that I do need to make sure of, is that when I get my 3 angles, I believe that angle A must be of a more lower pitch than angle B. So out of the two first results, whichever one is the more vertical one, I'm going to give to B, and whichever one is the more shallow one, I'm going to give to A, and the final one I'm going to give to C. And that's so that A goes out further and B comes back sharper to establish a height. So let's get A and B. So tolerance of 40 and 86. Okay, we've got 79 and 58. So what I'm going to do is I'm going to give A 58 degrees, and this, what was that last one there? It was, I think it was, let's do it again. 79. Let's go for 79. That just proves that I'm very much doing this randomly. So 58 degrees should be shallow, 79 degrees should be sharp. Now, angle for C, generate 66. All right. Now, that doesn't necessarily mean that it's a sign of the devil, but I know that people will think that because it came out 66, that I'm clearly working with the devil. It's complete from fucking garbage. All right, so 58 degrees. So let's start with a grey line. And let's rotate it 58 degrees. 58 degrees. Whoop. Now it goes the opposite way sometimes. That's fine. I can just undo it. So I can go rotate and I do negative 58. And it goes up that way. Now if I was to do a double check to make sure that we're all good. 58 degrees. Okay, we're all good. Now, I know that I'm going to have to do a negative on this one because the same problem as well before. So, negative 79 degrees. And then I'll triangulate it to this point here. So, I've got my 58 degrees here to point X, and I have my 79 degrees to point Y. Now, my downlight is over here. Something tells me that this is going to end up being a lot smaller than the actual room, and I'm going to have to move my friggin' sharks in. I think that for the sake of this, I should increase my tolerance from 66. Let's reduce it down to 30, and let's reduce this down to 60. Okay, we're going to go for 34. Alright, so I'm going to change it to 34. You can see that it's all completely on the fly. I am really just fleshing this out as it goes. So what I'm going to do is I'm going to move this angle up here because I never end up using that. So I'm going to move my ceiling down to this point. Alright, so that's where my ceiling is. And I'm going to go and stick my little downlight feature. And I'm going to name that thing D1, as it said in the instructions. So D1. Okay, so that's downlight 1. We got angle 58, angle 79. Something tells me this room is certainly going to move across. So I'm going to move this floor node over here. I'm going to move the cutting in the ground. And the sharks are gonna come and attack us. Oh dear, oh dear. Very dangerous stuff. Now, what are we gonna do here? So over here, we got 34 degrees. So let's triangulate this point here. And we will go positive 34 degrees because it's going in the opposite direction. I know this because the other one went negative. And I'm gonna sneak that down there. And guess what? Because I know that I'm 300 out and I'm at a 34 degree angle, which I can verify just here, 34 degrees. And if I extrapolate that to the ceiling, what I can do is if I move the floor node over here and move out our busted floor over there, and I can I'll move this down over to here. I can move the entire thing across to triangulate with our downlight. Okay, friggin' sharks are happy They're very, very happy. They haven't been fed in weeks. They are really hungry, but at least they feel happy in their little hole. Now, as you can see, I've managed to establish a ceiling height and I've managed to establish a room width. Now, what is the result? You're seeing this live. Okay, 22.9. That is the ceiling height for this particular room. It's below the code because I'm pretty sure we're supposed to be a little bit taller than that. And the room width is 5495.4. So as you can see, we even with this sort of units, if we've got some sort of base unit that we can model our angles with, and we can use angles to a particular light in the sky, we can establish how high our ceiling is and how wide our room is quite easily. We have a result. So, you know, Flat Earth Dave saying you can't measure what the Earth is by looking at lights in the sky. You're an idiot.